Hello and welcome to this video. In this video we're going to be talking about how to solve questions with algebraic fractions. So when we're looking at algebraic fractions, nothing has really changed from looking at regular fractions. When we look at regular fractions, they can ask you to add them, minus them, multiply, divide them. So just as a very quick recap, if we were to add fractions, so let's say we wanted to add 2 over 5 plus 3 over 2, we have to make sure their denominators are the same, and so this would become, we want to make both of them 10, so this becomes 4 over 10 by multiplying top and bottom here by 2, and this one becomes 15 over 10 by multiplying top and bottom by 5. And then when we add these together, we get 19 over 10, and this is our fraction. Let's say we were going to add x over 4 plus 2x over 6, maybe. We do the exact same thing, okay? We just want to make the bottom numbers the same. We're going to make this 24, since that's, actually, let's make it 12. So we'll times the top and bottom by 2 on this side, and times the top and bottom by 3 on this side. That's going to be the lowest common multiple of them. So we're going to get 3x over 12 plus 4x over 12. That's going to give 7x over 12. So nothing really is different with these. We can do the same with minusing. With minusing, we also want to get a common denominator. So this was adding. Let's do subtracting over here. So subtracting, let's say we wanted to subtract 3 over 2 minus 2 over 5. So just the opposite of what we've done here. We'd want to make this is going to become 15 over 10 minus 4 over 10. So it's going to become 11 over 10. So that's how we would do a regular numerical fraction. If we wanted to do 2x over 6 minus x over 4, we do the exact same thing. We're going to make this into 4x over 12, just like before, and we make this into 3x over 12, just like before, and this becomes x over 12. So nothing has changed. If we wanted to multiply things, multiplication and division, if we wanted to multiply fractions, if we had 1 over 6 times 5 over 4, if we wanted to multiply these together, we just multiply the tops and get 5, then multiply the bottoms and get 24. See if we can simplify it. We can't in this case, so we leave it like that. Same exact thing for multiplying algebraic fractions. Let's say we had x squared over 3, and then we had multiplied by 4 over 2x. In this case, the multiply tops together, we get 4x squared divided by 3 times 2x gets 6x. This time we can simplify a little bit. So we can simplify by dividing the numbers by 2, but also x squared divided by x is just going to give us x. So one of these x's cancels with this 2, and this becomes 2 out of 3. So this is the same as 2x over 3. But again, the multiplication part is no different. And finally, we have dividing. So let's say division. Let's say I wanted to divide 6 over 7 divided by 3 over 2. Okay. Method for dividing is we turn this into a multiply and we flip these, so it becomes 6 over 7 times 2 over 3. That's going to become 12 over 21. Both of these things are divisible by 3, so we can simplify that to 4 over 7, and that's not simplified. That can't be simplified any further, but exactly the same. Let's say we wanted to do x cubed over 2 divided by 2x over 7, maybe. This, we flip it, it becomes x cubed over 2 times 7 over 2x. This becomes 7x cubed over 4x. Now the 7 and the 4 we can't cancel, but we can cancel one of these x's with one of this, so that's going to become 2, and so your answer is going to be 7x squared over 4. Okay, so the fundamental basics of adding, subtracting, multiplying and dividing fractions has not changed at all. But most questions aren't going to ask you to do this. Most questions will ask you just to simplify fractions. So how we've simplified fractions before, when we simplify, so we're going to look at simplifying algebraic fractions. Whenever we simplify anything algebraic, step 1 is to factorize as much as we possibly can. So let's try quite a difficult example. Let's say we got given a fraction that was x squared plus 5x over x squared plus 7x plus 10. So our first step is factorize both the top and the bottom. Okay, and you'll usually find that if you're factorizing it, you're usually going to find that things are going to cancel out. So hopefully they do. So in this case, on the top, in order to factorize this, I can take an x out of both of them, and it leaves me with x and x plus 5. And on the bottom, I'm looking for two numbers that multiply to give me 10, but add to give me 2. So that's going to be 5 and 2. Sorry, they add to give me 7. Getting ahead of myself. They add to give me 7, so that's going to be 5 and 2. So this is going to become x plus 5, x plus 2. And so you can see here that we can cancel those two, and that will just leave us with x divided by x plus 2. Now, fair warning here, this is a very common mistake that people will make. People will see an x on the top and bottom here and think, okay, I can cancel this, and then that's equal to a half. That's not true, okay? We can only cancel things out when they're being multiplied. So this is x times this, and this is x plus 5 times this. So we can cancel these because they're being multiplied on the top and on the bottom. This x here is being added on the bottom, so we can't cancel it out, okay? So this is our final answer for this simplification, okay? So they can ask you to add fractions together and then simplify them. They can ask you to divide, multiply, subtract fractions and simplify them. And so the adding and subtracting, multiplying, dividing is exactly the same as it always has been. And this simplifying, we're just going to factorize, and then hopefully things cancel and we get a much nicer expression. So this is algebraic fractions. Thank you for watching. Hello and welcome to this video. In this video, we're going to be looking at some practice questions for algebraic fractions. So we're going to look at how we'd simplify them, how we'd add them, minus them, whatever the question may ask us. So this first one is asking us to simplify this fraction fully. So we said the first thing we want to do when we're simplifying algebra is always factorize. So in order to factorize, these are quadratics. So in order to factorize, we need to find two numbers that multiply to give us minus 12, add to give minus 1. And if these aren't immediately obvious, you can always go through the list of maybe 12 times 1, maybe 6 times 2. But this one, once you've done loads of practice, you'll be able to see that this is going to be something to do with 3 and 4. And you want it to be minus 1, so it's going to be minus 4 and then plus 3. So this is going to become x minus 4, x plus 3. And then on the bottom, we're looking for two numbers that multiply to give 20, add to give minus 9. Again, if this gets a little bit too difficult, you can go through maybe 20 times 1, maybe 10 times 2, maybe 5 times 4, and you'll see that 5 plus 4 is going to give you 9. So if you want negative 9, you're going to have negative 5 and negative 4. So that's going to become x minus 4, x minus 5. And now, as we hope for, we get something that we can cancel. And so this can just be written as x plus 3 over x minus 5. We can't cancel this any further because things are being added and minused. We can't cancel x's if they're being added or subtracted. Okay. So now let's go on to something a little bit more tricky. So we're going to do the same thing, but now factorizing this top expression is a little bit harder. So we're going to say, let's set this side aside just to factorize this first. So we've said that in order to factorize something with an a value that's not equal to 1, we need to find two numbers that multiply to give 3 times minus 4. So to give minus 12, but add to give 11. Okay, so two numbers that do this, minus 11 and minus 1. So we could write this then as 3x squared plus 12 and minus 1. So the two numbers that multiply to get minus 12 are going to be 12 times minus 1, and if we have 12 minus plus minus 1, it becomes this. So it becomes 3x plus 12x minus x minus 4. We split this in half down the middle. This becomes, we can factor out 3x, this becomes x plus 4, and this we can factor out a minus 1, this becomes x plus 4, and so this factorizes to leave us with 3x minus 1 multiplied by x plus 4. So this is our numerator now, so let's write it over here. 3x minus 1 over x plus 4. Now that's the top of our fraction. The bottom of our fraction is x squared plus 3x minus 4. And so in order to factorize this, we're looking for two numbers that multiply to give minus 4 and add to give 3. This is going to be quite similar. So in order to get minus 4, we could do 4 times minus 1. And so this is going to be x minus 1, x plus 4. And so we can put that here, x minus 1, x plus 4. And again, these plus 4's cancel. And so we're left with 3x minus 1 over x minus 1. And that's the form that we're asked to write it in. So we know we've most likely got to the right answer. Okay, so now they want us to simplify fully this expression. So this has a lot of x squareds and all of that kind of stuff in it. So first thing we're going to do before we start dividing and multiplying out, factorize everything first, and then that will simplify what we have to divide and multiply. Okay, so let's factorize. So this fraction, this first fraction here, can't be simplified any further, so we'll leave that one. We'll just simplify this one. So if we're trying to simplify x squared minus 4x plus 3, we're trying to find two numbers that multiply to give 3, but add to give minus 4. Now this could be minus 3 and minus 1. So we can write this as x minus 3, x minus 1. So this is our numerator. Let's put this over here, x minus 3, x minus 1. Then we have 2x squared plus 13x plus 15 along the bottom. We're looking for two numbers that multiply to give us 30, but add to give us 13. This is going to be 10 and 3. So we're going to split this up. So 2x squared plus 10x plus 3x plus 15. We factorize down the middle. We get 2x, x plus 5, and this becomes plus 3, x plus 5. And then we pull that together, we get 2x plus 3 and x plus 5. So we can put that over, we get 2x plus 3 multiplied by x plus 5. Okay, now we can look at what we had originally, which was 2x over 2, 2x minus 2 over x minus 5 divided by this. Now if we want to divide by this, we have to flip this and then multiply. So 2x minus 2, I'll keep this out of brackets for now, over x plus 5 multiplied by 2x plus 3, x plus 5 over x minus 3, x minus 1. Now this x plus 5 and this x plus 5 can cancel. So we're going to end up with an expression that's 2x minus 2 times 2x plus 3 over x minus 3, x minus 1. And there is a sneaky little bit of factorizing we can do in this case. This 2x minus 2, we can actually take a 2 out of both of these numbers. So we could now make this 2 times x minus 1 times 2x plus 3 divided by x minus 3 x minus 1, and now these x minus 1s will cancel, and if I expand this 2x, this 2 into this 2x plus 3, it becomes 4x plus 6 divided by x minus 3, and we won't be able to simplify that one any further than that. Okay. Now, let's have a go at looking at a minus 1, and we're actually asked to solve this equation. So let's first make this all into the same denominator. So in order to do that, what we've always done is multiplied them by each other. So we're going to have the 7 over x plus 1 multiplied by 3x minus 2 over 3x minus 2 for this, multiplied by top and bottom. So that's our first side, and then it's going to be minus 4 over x plus 1, over 3x minus 2 multiplied by x plus 1 over x plus 1, and that's going to be our second thing. So this is going to get us to be under the same denominator, and that's equal to 1. So this is going to become 21x minus 14 over, and I'm going to leave these in brackets for now, 3x minus 2 minus, and this is going to become 4x plus 4 over x plus 1, 3x minus 2, and this is equal to 1. What that means is that this is going to become, this is going to form 21x minus 14 minus 4x minus 4 all over x plus 1, 3x minus 2. Okay, that's equal to 1. I'm going to simplify this on the top and hopefully see some sort of factorization that I can cancel with the bottom. So 21x minus the 4x is going to give me 17x. So this becomes 17x, and the minus 14 minus the 4 becomes minus 18. And that's all over x plus 1, 3x minus 2. And that's still equal to 1. Now nothing actually cancels out here. We can't factorize anything out. So what we're going to have to do is multiply everything up here onto the other side. And so I'm going to continue with this up here. So that's going to become 17x minus 18 is equal to x plus 1 times 3x minus 2. Now I can expand these brackets. That's going to become 17x minus 18 is equal to 3x squared plus 3x minus 2x minus 2. Now let's simplify that side. This is going to become 17x minus 18. Bring the 3 and the 2 together, becomes 3x squared plus x minus 2. Now I'm going to move everything here onto this side, and this is going to become 0 is equal to 3x squared. X minus 17x is going to give me minus 16x, and minus 2 plus 18 is going to give me plus 16. And now I want to solve this equation, so let me just rewrite it out in a way we're probably more familiar with. Like this is equal to 0. So our initial idea would be to try and think of things that can factorize to get to this. So if I tried to find things that factorize, I'd be looking for two numbers that multiply to get 3 times 16, which is 48, and add together to get minus 16. Now, things that multiply to give me 48 are going to be things like 48 and 1, 16 and 3, but also things like 6 and 8. And if we had 6 plus 8, we're only going to get to 14, maybe 24 and 2, maybe a 12 and 4. And there we go. So we're going to have something that's going to be minus 12 minus 4, and that's going to give us this factorization. So we're going to have 3x squared and that's going to become minus 12x minus 4x plus 16 is equal to 0. I factorize down the middle here. This I can pull out a 3x. This becomes x minus 4. And on this side I can pull out a minus 4. And that's going to become x minus 4. This becomes 3x minus 4 multiplied by x minus 4 is equal to 0. And then I'm just going to move up so I can get some extra space. Therefore, either x minus 4 is equal to 0, in which case x is equal to 4, or 3x minus 4 is equal to 0, in which case x is equal to 4/3. And these are our two solutions. So really, a lot of this question has been difficult because we haven't actually done many algebraic fraction things. We started off, but as soon as we get to this point here, and this part, from there, it's just solving the quadratic equation. So hopefully all this makes sense. Thank you for watching.